Welcome to a journey through everything we know and don't know about the edge of the universe. Measurements show that light from distant sources shifts in wavelength as space expands, a process that began billions of years ago. This redshift isn't just a scientific detail, it's a signature of change, etched across time and space. Light stretches, colors fade, and from that, we learn how the universe once clustered tightly before slowly unraveling into what we see today. This slow expansion is more than movement. It's a story, one told in the colors of ancient starlight, in the way galaxies drift, and in the quiet retreat of matter across the vast, cold black. A story not just of stars and galaxies, but of us, our presence. A brief flicker still fits into this endless cosmic timeline. Today, we'll follow that thread, tracing the ever-expanding fabric of space and asking one of the biggest questions there is. What lies beyond the edge? Imagine standing under a clear night sky. The stars above you seem fixed, eternal, but they aren't. Every one of them is on the move, and not just because they orbit something or drift through space. The space between them is stretching, quietly and constantly. This isn't motion as we normally understand it. It's not objects flying through the void. It's the void itself expanding. And the way we know this is through something called redshift. When the light from distant galaxies gets stretched into longer, redder wavelengths as it travels through space. That red hue isn't accidental. It's the universe whispering, "I'm growing." The earliest measurements of this shift were like watching a balloon inflate. Each point on its surface moves away from every other point, not because the points are traveling, but because the balloon itself is stretching. That observation shattered the idea of a fixed universe. Instead, it gave us something stranger, more elegant, a universe constantly in motion, reshaping itself, one quiet moment at a time. In the beginning, the universe was dense, packed with energy and raw material. Gas clouds collapsed under gravity, forming bright, energetic stars at a furious rate. But as space expanded, that material grew more and more diffuse. The conditions that once made starbirth easy became rare. The universe started to slow down. Over time, this thinning of matter changed everything. Fewer stars were born, galaxies became quieter. The energy needed to spark new stellar life just wasn't there anymore. Slowly, a vibrant universe faded into something older, more isolated. We see this story written across the sky. Spiral galaxies still form stars, fueled by their arms of gas and dust. But elliptical galaxies, they've nearly stopped. Their once rich reserves of gas are gone. Only old stars remain. And the expansion of space makes it worse. With so little material left to form new stars, they grow dimmer, colder. Each star follows the same arc. It burns bright while nuclear fusion powers it from within. But fusion can't last forever. When the fuel runs out, the light fades. Some stars end in spectacular explosions, others simply cool into silence. But all come to the same fate, stillness. This process doesn't just mark the end of individual stars. It marks the quiet decline of entire galaxies. When gas is gone, the cycle of birth and death halts. New stars stop forming, old ones grow dim. Entire regions that once blazed with activity become cosmic graveyards. And over time, the universe enters a phase of long, gradual dimming. Even red dwarfs, the most resilient stars, burn their fuel slowly but surely. Over trillions of years, they too will fade. Their glow will vanish. Their warmth will die. And all across the sky, what was once a brilliant tapestry of light becomes something colder and emptier. This is where the universe may be heading, a slow fading into darkness, a scenario called the Big Freeze. As expansion continues, energy spreads thinner and thinner. Stars burn out, black holes evaporate over time. Eventually, the universe reaches near absolute zero, a place where no light shines and no movement stirs. A final quiet that stretches into eternity. But what if the end isn't quiet? There's another possibility, more violent, more dramatic, the Big Rip. If dark energy, the strange force driving expansion, grows stronger, it could eventually overcome all other forces. First, galaxy clusters would unravel, then galaxies themselves. Stars would drift away from each other. Planets would leave their orbits. Even molecules could be torn apart. Matter itself would break down, all structure lost, all bonds broken. In this scenario, the universe doesn't just fade, it tears apart completely. Still, some theories suggest a different fate entirely. What if expansion stops? What if, one day, gravity wins? In a theory called the Big Crunch, expansion reverses, galaxies slow, then fall back together. Space contracts, temperatures rise, the universe collapses into a single, unimaginably dense point. And at that moment, at the very edge of understanding, something else might happen. Another Big Bang, a new beginning. In this view, the universe isn't on a one-way path to extinction. It cycles, expanding, contracting, rebirthing again and again. But while we look outward, there's something else pulling us inward. Our Milky Way is moving fast, faster than it should be, not just because of expansion, but because something enormous, invisible, is tugging at us. It's called the Great Attractor. We can't see it directly. It's hidden behind the dense stars and dust of our galaxy. But we can feel its gravitational pull. It's not a single object, but a region packed with mass and dark matter so massive that it affects the motion of hundreds of galaxies, including ours. It raises a new question. If something so powerful exists so close and yet unseen, what else lies beyond the veil? The truth is, the edge of the universe isn't a line. It's not a border. There's no wall, no boundary. Space doesn't expand into something. It expands itself. The observable universe, the part we can see, is limited by light speed and the age of everything. Beyond that, it may be more of the same, or it may be something else entirely, something we'll never reach, never know. And maybe that's okay. Because in asking the question, what lies beyond, we move closer to understanding the universe we're in. And while the cosmos fades, our world is bursting with change. Climate shifts, new technologies, rising risks. Unlike the slow march of stars, our timeline is immediate. But the same curiosity that pushes us to look at galaxies also pushes us to protect what's here. Same science that studies expansion also helps us survive. And so, the edge of the universe isn't just a place, it's a symbol. A reminder that the unknown still calls, that questions are still worth asking. Here at the New Space, that's what we do. We ask. We wonder, we explore. If you want to keep going further, past the galaxies, past the starlight, past what we can see, subscribe. Because space doesn't end, and neither does curiosity.